Thank you. Everyone, just a quick show of hands. How many people here are familiar with OTOY or Octane? Okay, great. So I get a chance every year to talk about where we think rendering's heading, and obviously if I'm here, I think that GPUs are a really big part of that. And as a company, we're really focused on not just GPU rendering, but the entire workflow that goes around capture and publishing, and ultimately we want to see the software that powers the holodeck come to life. That's a really important mission statement for me, but it's also something really fundamental to democratizing media and workflows. And when you ask the question, what's rendering going to look like, in an ideal form or an ideal state, it was interesting. I was just on Twitter, and the other day, Tim Sweeney posted this. He said, what are the attributes of this ideal programming language if you had infinite compute power, and it was designed for maximum productivity? And my response was, well, it's basically magic. If you have something that's connected to your brain and you imagine something and it's realized, well, that's ultimately the ultimate form of rendering. And as you look into the 2020s, you start to really see a convergence of a lot of interesting fundamental parts of the rendering process. Photorealism is very obvious. It's something that's mandatory in CG and visual effects. But also you're seeing this being merged with real time, and you even have Unreal Engine 4 now being used for shots in Star Wars. That's huge. That's really huge. And I think the most important third piece to this flow, really to make it feel like magic, is for the tools in the workflow to be effortless, for the creative output to be something that comes from pure creative energy and without much of the tools getting in the way. And you start to see that happening with tools like Tilt Brush, where you're literally just painting in space. It's built on a game engine like Unity, and it's something that's shareable, and it's backed by Google. So you have a sense of where things are going just from these early trends. Now, from our perspective with Octane, we've been doing this, this path, trying to get unbiased GPU rendering, into workflows everywhere for many years. We started in 2010, and we've sort of had a release of Octane almost every 2 years. These major, 1.0, 2.0, 3.0, they almost happen, if you look back at it, almost every 2 years, and we're trying to cover different parts of the, of the workflow. And with 1.0, we really could just do images, and in Octane 2, we cracked animations. And with Octane 3, which is where we are today, we really wanted to get everything that you would do in the CPU and the traditional legacy rendering pipeline to happen on the GPU and to offer the benefits of that. And the good news is I don't think we're alone in this effort. I mean, you have the Redshift guys who I love, that are working on the biased GPU rendering workflow, which is genius. And we're all trying to sort of crack this problem and sort of get legacy rendering out of CPUs and onto the GPU. And I don't think there's a major rendering toolkit today that isn't thinking about GPU rendering if they don't already have a solution in place. But for us, I mean, beyond Octane 3, we announced last year we're going to do an Octane 4, and that focus is going to be on the real-time workflow, and it has to include everything that came before it in order to get to what's coming, which I think is something that's even more fluid than real-time. So just to recap sort of where we were since last year's GTC, we had a lot of really good milestones. We launched Octane 3 about a week after GTC last year. We introduced subscriptions, which is part of my plan for democratizing access to GPU rendering, and it's been fairly successful since we launched it earlier this year. And we've had 2 major partnerships connected to Octane, Unity and Facebook. I'm giving a separate talk on VR workflows, and both of these partnerships are related to that. And we're about 70% of the way through Octane 3. So we're, linearly, it's going to end at Octane 3.1, where we add open shader language. But right now, we are about to release Octane 3.07. And the results of the version 3 cycle have been really good. I mean, I do feel like, if you look at the opening Westworld done in Cinema 4D for Octane, it's beautiful. And, you look at that and you really can't imagine that it would look any better if it were done on a CPU renderer. And I think that the value of what we provided in this kind of workflow is that it was done without even using the cloud. It was just done on a bunch of GPUs locally. And I think that going forward, we want to see Octane integrated in even simpler workflows. So Unity is a great example of that. We announced a partnership with them in November. And the partnership's really important because for us, I mean, the only way to go lower than $20 a month is to give Octane away for free. And that's what we're doing. And we did this before. We did an Octane VR 3-month free trial, and it did dent sales. But I think the most important thing is we want to see the core of Octane, and we're not even going to label it as such. I mean, it's more about adding really correct GPU and physically correct base rendering into Unity, and there's 7 million Unity customers and artists who are going to get this. And I think that that's also our ingestion point to be able to do things that we know are coming down the line, like being able to bake into light fields and feeding that back into a game engine. So that's something that is a big part of our future. And then on the other side of our partnerships, we actually have Facebook, which is creating, believe it or not, an Octane plugin for volumetric video. And they actually, because of this partnership, we're accelerating our integration of Octane into Adobe After Effects and Nuke. And of course, we have Unity. And the thing that all of these things have in common is that they are video workflows. I mean, Unity has timeline. It's meant to do cinematic VR. But Octane's providing a on-ramp for these kinds of volumetric experiences. And volumetric video is actually pretty hard. So my second talk will focus a lot on that. Back to the actual features that we're rolling out in the next month for Octane 307. Orbex importing. So Orbex is an interchange format that works across almost all of the 30 now Octane plugins that we have, and now you'll be able to import them, very important for Unity. Also, the Octane standalone interface is something you can now bootstrap into all plugins. And just to basically solve all the problems we had to integrate into a game engine like Unity, we have operator nodes, frequency and transform nodes, and we're also supporting FBX and GLTF directly in Octane. There's a lot of other layers that are coming in the next month. Native CAPI framework for nodes that allow you to do procedural images, geometry, compute nodes. You can also take anything that you can render in Octane and feed that into the texture synthesis system, and that allows you to do baking or even do pre-computation of light maps. And you can also set up jobs that can be handled on both the cloud and locally, and we're adding things like custom LUT support and fake volumetric lights, basically to match the Unity Spotlight system. So this is an image of the Unity engine with the standalone UI, pretty much all of it running inside of the Unity UX. And what's really cool is that you can mirror what's going on in the node system. Unity doesn't yet have a node system with Octane. And it's very powerful. There are things that really can only be done in the Octane standalone UI and a number of plugins. Unity, in this case, doesn't have a lot of these features, but you can still edit things in the normal Unity UX wherever there's a parallel value or target, and that includes things like the physically based camera system. And with Unity, we're actually working towards merging their physically correct camera with ours, and it's really cool. We're learning a lot, and we're changing a lot in Octane to sort of support these kind of game engine workflows. This is a new feature we're adding in 307. We have native bone and skinning support in Octane, so you can load in FBX, or you can drive a real-time motion capture rig, and basically this is running bone and skinning with displacement, and it looks pretty good. And the other piece that we're adding in this release is gizmos that allow you to transform scale, basically move objects around in the viewport, in the path trace viewport. Hasn't really been possible prior to this release. And this is an example showing render to texture. So we can take one chunk of the unbiased rendering workflow and bake that into a texture and feed that back into another render target. And to that end, a lot of what we want to do with this module system, this CAPI, is provide a system to give developers and artists a whole bunch of procedurals. Some of those we had to create just to map to Unity. But there's a lot of really amazing modules that can be built. And beyond 307, as we get to the next two releases towards the end of 3X, we've added, for example, a module that does vector displacement mapping. And that was something we weren't sure we could really do in Octane, but it actually is a hybrid approach. It does low poly cage mesh from the position map, and then it does regular displacement mapping for the rest of it, and it actually works. So the module system is going to be something that first and third parties can build on top of. There'll be a CAPI you can drop into the node system. But with this system, we know we can get UDIM. It's already something that's supported in one plugin. We just want it in all of them. PTEX. We're going to try to do an open FX wrapper, so you can use things like Neat Video directly in the Octane viewport. And it's going to be pretty easy to add things like dynamics, physics, and IK, because we've basically tested those things with the Unity integration. And then if you really don't like Lua, which is our default scripting language, you can build new ones with the CAPI and create a VM. Some of the other low-hanging fruits, features that we know we want to get into the next 2 releases, custom mesh attributes, modules that can load in things like USD, GLTF 2.0, and we're also going to explore MaterialX and MDL probably as an external tool. And then we're also going to have UX, basically full mini applications that can edit parts of the node system. And we're specifically thinking about Substance and Houdini. Houdini is an engine, Substance is a procedural texture system. And we want to be able to have it so that even if those textures are baked, you can still load up those 2 tools and mess around with their internal node systems. And then the other thing we can do, since we have hooks into the node graph, is to change the way that the geometry and even the assets are loaded into the viewport based on where you are. It's not completely unbiased, but it's something that we think people may want to use. The other thing that we've decided we just want to do and need to do is Boolean rendering, so you'll be able to basically do geometry clipping. And we're going to have another round of improved caustics, better rounded edges. We're about halfway through that. And we're also going to have at least several different modes of subsurface scattering, including the AL surface SSS, which we think is pretty nice. And we're also going to improve hair shaders, specifically fiber effects for Lightwave. And we also have a whole new approach to doing faster volumetrics, which we're going to be introducing before Octane 3.1. So the other important step function for us is getting Octane to work on pretty much all devices. I mean, when we're shipping with Unity, a good number of those people don't even have a GPU. They have a Intel integrated graphics or maybe an AMD GPU. A lot of them are on the Mac, so Mac is critical for us. We have to figure it out. And you may be familiar with our cross-compiler technology. This is something that we built to support bringing Octane with all of its CUDA source code onto other devices. So since our last GTC, we've actually figured out how to get this running on x86 and even Intel integrated GPUs. And what we found was that the Intel integrated GPUs are about 4 times faster than the 8 or 16, I guess, CPU cores, but we can use both. But either way, the other thing we confirmed is that a discrete graphics card just destroys either of these approaches. But the one thing that going on the Intel GPU does allow is that you get out-of-core or you get system memory textures and geometry, and that's very important. So if you do want to use this path, it will give you full GPU speed, at least on Intel integrated graphics, in system memory. It's something that we're kind of on the fence about supporting this year just because of the drivers, but we think it can be addressed. So going into 3.1, and this really is sort of the capstone for us of the offline rendering pipeline, OSL has been a really important and difficult piece for us to get working in a GPU renderer without breaking everything else. I mean, Octane has 6 years of users and they have scenes and nothing can break. So the reason why this took so long was that we are converting every single thing in Octane that was never done with OSL, particularly in mind, into OSL. And now we can add completely new OSL shaders. You can literally, I just loaded up the Octane webpage, the Arnold webpage last night for Arnold 5, and I just copied OSL code, and it works in Octane. The V-Ray Flakes shader, which I also just copied from the webpage, you can drop in and you have their, the texture map for their normal flake shader, which is cool. But anything works in this thing. I mean, you can basically load in a Mandelbrot set and it's running live, and it's awesome. I mean, this basically opens up the door for a lot of crazy procedural texture effects. I mean, I want to see font rendering, distance field, SVG rendering, all these things, definitely approachable. Even before OSL, we do want to make sure we cover all of the nodes that we can think of, but there are things that are obviously going to be outside of that system. So this is the way that OSL is integrated in the node system. You essentially can just drop in OSL code. The metadata defines how the pins are generated, and it works really well. It's actually very simple to use. The other features beyond OSL that we're going to try to get into 3.1, we want to have different BRDF options beyond what's built into Octane. That's obviously going to be possible with Octane 3.1 and OSL, but we want to support that explicitly. And we're also going to move up Brigade's light sampling from version 4 to version 3, which will improve speed a lot. Improvements to IES light sampling, and then we're going to have better lens distortion effects. We're also going to introduce a metallic shader. I think it's just something that people are used to and they want. We're going to have glossy Fresnel modes, optical vignetting, OSL light mixer. Light mixer is something people have wanted for a while, and there's no reason not to do that with OSL, especially since we can now basically render the textures in the node system. And we're going to have custom shutter types, And the other thing that we experimented with in a test build of Octane has been blue noise sampling. It does seem to significantly improve quality and speed, so we're adding it. And that's pretty much our Octane 3 roadmap. The other complementary layer to Octane, of course, is our cloud service. And we try to make that as transparent as possible. We rolled it out last year as a test drive. We basically let people subscribe to it for free. And we gave them a certain number of credits. But we actually did see some great usage. Black holes done in Lightwave, 12 minutes rendered on Orc, all of it. And it's awesome. I mean, it was great to sort of see that workflow be validated. So after we release Octane 307, or around that time, we're going to have a new Octane bench, and we're going to actually introduce paid Orc subscriptions. So the way we're doing is we already have subscription pricing. If you choose to use Orc, you can think of it as a Octane integrated plugin. So you can choose Orc in place of Cinema 4D. And one of the things that we decided we needed to do was have it so that your Orc subscription is like a passport to other cloud services, even third-party ones that just don't fit into the Orc workflow. So things like Deadline, you can use that. We've also come up with essentially the minimum viable paid bucket, $5, gives you 400 Octane bench. Rather than GPUs and minutes, basically Octane bench per hour is something that people can map very easily to their local workflows and then understand what they're paying for on the cloud. If you want to go cheaper than that, you can set the deadline for a week instead of 24 hours, and you can also define $1 per frame cost. And we're going to let third-party render farms finally come into the ecosystem and bid on these $5 buckets. If they can do better than sort of the blended service we have, that's terrific. They just need to be reliable. So this is sort of a screenshot of the new workflow. You can see there's some new parameters in there. You get cost estimation built in. You can also map your render job to what your local GPUs are doing with Octane Bench. Octane Bench actually is a virtual currency at this point. And then there are other services we're building into Orc, such as a full WebSocket API, and this is Octane Engine. The entire Octane UX is actually recreated in HTML5, and you can use Octane entirely through WebSockets. And if you want to build a web-facing service, you can do that rather than a native plugin, and that just hooks into your Orc account as well. So subscriptions already in place, $20 a month, max 2 GPUs, but we're adding a whole bunch of other built-in layers and plugins into that subscription plan starting in the next couple of months. So we already have Unity covered. Unreal Engine 4, which we're working on, will also be part of that. There'll be After Effects Nuke, basically the same plugins we were supporting in the video pipeline for Facebook, also included. And then we're also building a Fusion 360 plugin. So you get all those for free. Well, if you're $20 a month, then you can also choose an additional plugin of your choice. And then we're also adding an even higher end subscription that'll be equivalent to the high-end Adobe Creative Cloud pricing, pretty affordable. You get access to all Octane plugins. You can use all GPUs that Octane currently supports, which is about 20. And you also have access to other cloud services like Imager and Engine jobs. And the price, I think, is pretty good. So this is, again, sort of a quick overview of some of the subscription offerings. This is the Fusion 360 plugin. With the stuff that we've done in 307, it's now like 6 weeks to build one of these plugins. It's much faster. I mentioned Octane Imager. In addition to Octane Imager, Imager is a whole separate pipeline for us that we use for processing the output of a render job, and it can actually do a lot. Since last year, we showed off how to do toon rendering, and now there's an SDK for it. But it is something that we're going to be using to allow you to take pre-computed data, like light fields, and drop them in to the compositing workflow. And you'll be able to sort of mix and match that with the actual render graph. So that's something that kind of invites us to think about Octane Imager almost as a different kind of renderer. It's always real time, but it's starting to do things that Octane did. For example, we're migrating the direct lighting kernel into Octane Imager. It can do GI, AO, reflections, in addition to toon shading. And it does have a denoiser. This is our real-time denoiser. It's doing live ambient occlusion. It's pretty close to the Octane version, but it's totally in real time on a single GPU. And it's not just for GI. It also works really well with reducing noise and reflections. And so we were sort of teasing up to this presentation that we have some ideas for built-in denoisers, and this is one of them. This is the real-time one. But ultimately, the way to sort of deal with noise is to not have it in the first place and to make everything real time, and that is the goal with Octane 4. Octane 4 is basically, there's really just one major feature, which is to merge our game engine path tracer Brigade, which we've been working on for years, into the cinematic workflow that Octane already has. And what's crazy is that there is a way for this to be completely in real time, and it's on ray tracing ASICs. So we tested in the last year PowerVR's ray tracing hardware, and it is 10 times more efficient than us writing the same code on on a discrete GPU. In fact, we're able to sort of get 150 million rays, which is what a 680 gets on a 2-watt chip. And it can scale up to 120 watts, 6 billion rays a second, which would mean Octane in real time, no noise, 720p on a single GPU. So whether it's PowerVR or somebody else, somebody needs to build ray tracing hardware. It is fundamentally important for the future of what we're trying to do here. We're also going to be adding out-of-core geometry on the GPU in V4. We've gotten this working in Brigade. And I think that beyond real time, we really want to think about how we can simplify the workflow. And going beyond sort of that version 4.0 release, there's going to be a lot of work that we're going to be doing around deep learning. Obviously, that's something that's pretty fundamental to NVIDIA's product roadmap. So we've already started to build some deep learning nodes in Octane that will even be available in Octane Imager and in the next few releases. Super resolution and deep learning-based denoising are at the top of that list. And you can see here, super resolution is awesome. I mean, it does give you this insane amount of augmented detail, and it is something that works in real time. And it's way better than any sort of filtering upsampling that we've sort of been able to validate it against. And it is extremely promising. So beyond that, I mean, our work with AI and deep learning is probably going to focus a lot on ingestion. So the Facebook 6-stop video data, for example, being able to turn that into materials, objects, separate parts of the scene, do object segmentation, even do look at an image, and this is what deep learning is really good at, and turn that into a scatter node in Octane and decompose a scene into tables. These are all things that are really valuable for deep learning, and it'll make the workflow again almost magical as you sort of move forward down the path towards sort of this simplified and infinitely computable real-time rendering workflow. And then we do think that deep learning probably is going to allow you to almost create art with natural language or even predictive input, and that is something that is obviously a stretch goal, but it's something that is probably not impossible in the next decade. So that's it. That's how we look at the future of GPU rendering. I think we have about a couple minutes for questions, if there are any. Thank you very much. Thank you.
Thank you. Thank you, Jules.
So what is the frame rate achievable with Octane Renderer for WebVR? Just if we have a WebVR application and we want to stream our WebVR, we want to tie into Octane, what are the frame rates we can achieve?
So that Octane engine thing where you can run the entire Octane application in a web browser, so that is no faster or slower than the Octane app itself. It'll probably run at 30 hertz with noise. If you want something that's faster than that, you have Octane 4, and you have all of our fancy tricks like the light field rendering and Octane Imager denoising. But it's basically, you can also go to OTOY.com right now, and you can run the Octane standalone application in JavaScript. And Octane Engine just basically separates that whole thing into a web service rather than loading a remote application. And therefore, you can really get into the core of the Octane Engine and build whatever you want as a front end in the web. And yes, you can use it to power, for example, cloud lighting for WebVR textures. So definitely, WebVR is an important target for Octane Engine as a web service.
Any other questions?
Yeah, you guys mentioned faster volume rendering through spectral decomposition tracking. How much of a speed up are you guys kind of expecting to get?
Sorry, I didn't quite hear the question.
You guys mentioned improved faster volume rendering as an upcoming feature through the spectral decomposition tracking stuff. Just out of curiosity, how much of a speed up are you guys looking to get?
Yeah, I don't know. I mean, we haven't implemented it yet. We just know that it's something that can probably offer maybe doubling of speed. I mean, there's, right now, volumetrics in Octane, because they're brute force, can be slow. The other thing we're going to do, and I think this is something we can definitely speak to, is that step function, when you have you have to select sort of a step by meters, that'll go away. Like, that's something that this will also do. And along that line, it'll also improve rendering significantly. It'll be seen and viewpoint dependent in some respects, but I think it'll probably double the speed. And if we're wrong, we'll let you know. But I mean, that's kind of what we're hoping for.
I guess that's about it. We're about out of time.